So we are going to start at 11.2. It's really just one example we're going to do today, but there's two parts of the question. So rates of change, two types of rates of change. You can do an average rate of change, or you can do instantaneous. An average rate of change, the way you calculate it is how a graph changes in regards to y as compared to how something changes in regards to x. You've seen this before. What is this? It's gradient. This is gradient. We are going to be doing a lot of gradient work for the remainder of the year, and it's basically the biggest topic. You might think in year 9 that gradient was just one concept. It is one concept, but it's a big concept, definitely methods. So change in y, remember, it's a subtraction of y2 and y1 and a subtraction between x2 and x1. That's all it is. Now, what does that look graphically? If you have a curve and they're asking you how does the graph compare from here to here in regards to how far it's changed? As you know, what we're really doing is creating a triangle of a rise and a run. That's all we're doing. Two dots, and between them, create a gradient that we call the average rate of change from what to the left to the right. Now, the new concept for everyone here, or maybe you've seen this before, is something called the instantaneous rate of change. It's what's happening at only one point in time now. So no longer it's two dots, but we're looking at what is the gradient at that dot here, that only dot. And the way we do that is a tangent. So does anyone know what a tangent, the real definition of a tangent, can anyone explain what that means? Tangent. You can just search it up if you want. Yes, Tim, what does it say?
A straight line or plane that touches a curve or a surface at a point, but if it extended, does not cross it at that point.
Okay. Does that make sense to you, Tim? That's right. Okay. All we're doing is applying a ruler onto the curve, but it's at 90 degrees at that point. Now, so over here, like so, you can see it's perpendicular right there. We've got a positive gradient happening over here. If I move it up to here, I'm going to keep it flat on the surface to make that 90-degree angle. I should have put the square in. Notice how the ruler has changed. Is it steeper or less steep than before? It's steeper. Flatter, steeper. If I pick on this point here, I would get someone to come up here, but I'm not allowed to be filming students. You would put it flat onto the graph, 90-degree angle. It's got to be flat. What happened to our gradient? It's now negative. Okay. It's now negative. Where would you put your dot so that the ruler has a gradient of 0? Where would you put that?
The bottom.
The bottom. Okay. Matty says bottom. Gabe says bottom. We put it here, right here, 90-degree angle, 0. This is all we're doing. We're just simply running a ruler just like that and looking at the gradient, the slant of this ruler all the way around. And then you can do it with cubics, whatever you want, quartics, something like that. Okay. All right. We're going to do one example here. Get my eraser. Any questions? Our question, equation today is this.
Seems like something.
Whenever you have an average rate of change, they will give you a boundary of x values from 3 to 5. So what are we going to do with the 3 and with the 5? Okay, Gabe.
Remember your active points to find wise for those values. And then there you can work out for any tools.
Yes, we can. Okay. We are going to sub them in. Now, you can get straight into it. Is everyone okay what I've just written? Remember, our y values are on top, but the way we can use our y values is we use the function of x. Remember, these are functions of x. That's y. On the bottom is our change in x's values. We're going from 5 to 3, or 3 to 5, but it's the change, so it's a subtraction. F5. How can I rewrite F5 right now? Okay. F5's 8. What does F5 mean? What's it asking you to do?
Define the x.
Define the?
Define the x value.
They've got the x value of 5, but what are we going to do with the x value of 5? What are we going to do it?
Put it into the equation.
Exactly. So put it into the equation. Subtract the function of x when x equals 3. Maya, what are we going to put there now? 3 cube. Is that what you're saying? Plus 2 times 3. 5 take away 3 is 2. Now, what must we always be mindful of when we're doing this? Sorry, Tim?
Minus.
Exactly. Minus the 2 times 3. Remember, that minus is a minus of the whole thing. That's a very easy mistake to do. 5 cubed should be 125 plus 10 minus 3 cubed is a 9 plus 6.
3 cubed is 27.
Is 27. Thank you. Thanks, 27. 2. Thank you very much. 135 minus 33 on 2. Okay. Should be 102 on 2, which is 51. Okay. Are you okay with that? That's the rate of change at 51. Any questions? What does that mean? If we did it visually, I'm just going to do a bit of a cheat on a graph. Now, you can even graph it if you want. X cubed plus 2x roughly looks like this. And what we're doing at 3, we can compare 3 and 5. At 3, we said it was 33. So this is 333. At 5, we said it was 135. It's not to scale. 135. That's all we did. 2 dots. And what we're doing is a rate of change between those two. So what I'm trying to say is this from here to here, that rating of the step is a rating of 51. It's quite high. It's very steep. Steepness of 51 in a way. Any questions? If you have a question, please let me know. We're now going to do the last question for today. The instantaneous rate of change. Now, as you can see here, I'm going to do a bit another graph. Let's get into this. This is just really rough. If you want the real thing, go on your CAS. This is still the same graph, but what we're looking at we're still focused on 3. Still focused on 3. Look carefully. 3 to 5. We're averaging 3 to 5 out from here to here. But what we're doing now, instantaneously, our ruler, our tangent has to be flat at 3. See how there's a bit of a change in gradient. From here to about there. It's a different answer. A bit down the track, we're going to give you a technique about how to calculate it instantly, just with the one number, with the 3. But today is just the introduction of instantaneous rate. The way they want you to do it in the exercise is if it's instantaneous at 3, you're going to need to get another point to help you out. Okay. So for example, I'm going to put it flat like so. And with my example, I kind of did cheat. I cheated. And so let's just, I know it doesn't look like it very much. Let's do this. If you do want to check my maths, you're in the exercise, you're going to just try to get a new point to work with. Okay. And you're gonna all have different answers because your ruler, the way you look at a tangent on a particular point, your graph is gonna, your judgment by eye is going to be different. By my eye, I'm going to say that this is 2.20. I've got a different set of points. You might get something else that you've read. You might get a point on the y-axis. You might get a point up here to use. It's a guess. Down the track though, you're gonna. Does anyone know how to do it? Calculus. Who's done calculus a little bit? If Emily, do you know what that is? Okay, it's all right. I'm not going to go there. that the calculus does things exactly right now today. You're not just going to use calculus. You're practically going to get a ruler and plant it on your graph. Let's do our work. So our instantaneous rate of change and let's just say the estimate instantaneous rate of change. Okay. We're going to do change in y and then a change in x as well. Okay. And so over here, we've just got 2 points. Going to minus them. Okay. 33. What am I going to minus?
0.
0. Because that's our y value. Okay. And then we're going to do 3. Take the 2.2. Just as you've been doing in 9, make sure that's one coordinate in the right order with the second coordinate. Finally, 33 divided by 0.8. Okay, if you put that in your calculator,
26.4.
is it 26.4?
Yeah.
I had something else. Oh no, 26.4. I think you're right. I made a mistake in my notes. Okay. Are we okay with that? So you can see clearly our rate of change is different between an instantaneous and an average because they're using different points.
No, the 26.4 is wrong.
Okay, what is it?
1.25. And it's divided by. You just called us now. Oh no. This should be lost.
All right. Oh, thanks, Gabe. Well,
So annoying.
that's okay, Zach. You're on YouTube now. Don't worry, I've made so many mistakes on YouTube. 41.25. Different. It's asking rate of change. Different definitions. This is only for one exercise. Later on, we're going to get into this weird stuff over here where it's really quick. And I'm not going to do that today. All right. Have fun with that.